So we are welcome to the weekly machine learning class, and where we are dealing. Last time we met, we stopped on dealing with missing data. How do we deal with missing data under the important clarifications risks? With the team, always let the data speak. So we reminded ourselves of the fact that this is the iterative process for machine learning model development procedure. And we made it very clear that you can see here we are at this stage, data preparation, or what we call sometimes pre-processing. We need to pre-process the data so that we'll be able to get the necessary insight that we are hoping to get from our data set. If the data is in bad shape, then even the smartest of machine learning algorithms may not be able to provide the needed insight. So, and these days, if we miss very important insight, then the such company may be on its way or a way out of business, because a single missed insight may spell doom for such corporation. So every effort matters to ensure that the machine learning model being deployed for the data analytics or data science processes is actually okay. So we need clean data. We need data that is reliable. So, and we discussed already in our previous videos, which for the sake of people who are just joining, you can check out our archive for some of the video on pre-processing activities. Yeah. So looking at we are here, this is why you do missing data is one of the very fundamental problems of data modeling. So if data is missing, so you have to treat. There are so many data pre-processing activities. However, we've identified missing data as the most important of them, or that you have to make sure that you carry out to ensure that your data insight is not compromised. After that, you are encouraged to go into modeling, check the performance, and then you can go back. Remember, letting the data speak. You don't ever go into too much detail about data preprocessing, because there are so many preprocessing methods or options or procedures that are optional. For example, normalization. Sometimes you have the normalization, which is often here. Normalization is an optional preprocessing activity, but sometimes normalizing your data may make you miss important insight in your data set. So let the original data speak, do the modeling, check the performance. You may go back, do hyperparameter optimization. You may have to go back to feature engineering to reshuffle the features. Maybe these features are not doing fine. If I combine two features to make one, do I need to break a particular feature into three? For example, we have date of birth, which has the day of the month, and also the year. I might decide to break it down into three features: day, month, and year, separated. Instead of one single feature, I make it to become three. These are part of feature engineering processes. So all these are optional. When we are not getting what we want or what we were expecting, that we need to go back. So that particular flexibility for you to always go back. You don't have to get it right at the beginning or at once. Let us pay attention to this. Otherwise, if you get yourself involved in much preprocessing, then you may actually miss the insight you are trying to catch. So we discussed this also in our previous video, where we determined how much of preprocessing is enough. Now, so we started the missing data treatment last time. We talked about what is missing data, what are the causes of missing data, and why is it required. So in the video on this missing data treatment, we presented clear case of this is usually what we're always expecting. This will always look into getting something like this. It's very easy data, but sometimes the reality may be as this. That is, you may actually have data that is not as you are actually expecting, some in text, some in video form, then you have to sort it out to be able to generate the one that is ready for modeling. So this is our dream data, raw data that you can easily put in Excel. It makes your life very easier. But sometimes you may have this complicated data set, and you have to find a way of putting it in a vision so that it will be ready for machine learning modeling. So we mentioned that we have major tasks in data preprocessing, data integration, data reduction, data transformation. However, we are for now focusing on the actual one that is referred to as the data cleaning, which is missing value, smoothing the data, identify outliers. So for now, we are dealing with missing values and how to deal with them. So we mentioned last time, there are some of the sources of missing data. So we can check out the first video of missing data for details on this. So it could be human error, it could be incorrect sensor, it could be software bugs that is responsible for you not getting the correct information you are supposed to get about your data set. So there are a lot of possibilities, a lot of things that could be responsible for such. So we discussed all this last time. And then we also presented why missing value treatment is required. That sometimes if you don't treat missing value, we confuse your system. And we give a particular hypothetical case here, a practical demonstration of how missing value presence can cause confusion in the modeling process. As we can see here, that because of this missing value, it's saying that female and male are 50-50. 1, 2, 3, 4. 1, 2, 3. Be able to have 50% and play cricket, 50% doesn't play cricket for male and female. However, when we were able to fit the missing value, we realized that actually female, there was 75% of female that can play cricket. But because the missing value, they're actually female, so we are going to miss the insight we wanted to generate from our data set. So we demonstrated this clearly, deeply, so that you know that missing value is not something to play with. It can actually change the entire system of your data. And we also mentioned to us that how do we deal with missing value? We said the first thing is to check the compute ratio, call it the missing value ratio. It's total number of missing value and divided by total number of values in that column. So if the missing value are really high, then we will have to remove that column. If the ratio is high, how many missing value do you have in a particular column? And then divided by total number of value in that column. That column, each column represents one feature. So in case the ratio is high, then it's better for you to divide, to just remove that column. This is one way of dealing with missing value. However, we said that the best way to deal with missing value is to go back to the original source of the data. Don't forget this. The best way to deal with missing value is to go back to the original source of the data. However, in reality, it's almost impossible in most cases, because some you don't even know who produced the data. How do you go back to them to ask for it? Sometimes you get this data online. Even you know the company, you went to them, say, no, those guys who work on this data, they are no more in service. It's been a very long time. In most cases, we are not able to get, but it's the best way of treating missing value, because we always want to work with correct value, authentic value. Every other methods of treating missing value is trying to introduce a kind of fake data, which we may have also consequence on your modeling. But once you cannot achieve this, it's not possible for you to go back to the original source, or you went back, but you are not able to get it. This is not possible. Then you move to the next option, which is for you to delete. The next available option is to delete. Either you delete the entire column or you delete the entire row. In that case, you are sure that it's another safer means of treating missing value. If you are not able to get from the original source to replace with correct value, then you can delete. It's on the safer side. You can delete if you have enough number of features. Let's say I'm having like 70 features. I can still afford to delete as many as even up to like 65. I may still be able to get good results. Even 67, you are left with only 3 features. It's still fine. We've built a very successful model on soil contaminant estimation using only 1 feature to do the modeling, and it was excellent. We got excellent results. So in as much as you still have features that are left, then you are in a better position, a better shape to keep deleting the number of the features that have so many missing values in them. However, if you are stuck with very few features, only 3 features or 5 features, how many will you delete? Then in that case, you may have to start deleting rows. That is record by record. Try to delete record by record. So it means you are going to delete row-wise. You look at the record and you keep deleting them. So you delete as many columns as possible, you delete rows, but sometimes if the number of samples making up the rows are very few, then deleting may not be an option. In that case, we move into the third way of handling missing value, which is imputation. Imputation method. Let's pay attention to that. The first one is to go back to the original source. I can get the original value from the source where the data came from originally. Number 2 is to do deletion. Delete some features that have so many missing values, and you may also delete some feature that has some samples that have so many missing values. If those are not an option for you in the order itemized, then the next thing is to have imputation method. That is trying to find a way of inputting the data. So regarding the deletion option, or this is where here, for example, here you have, we said, unless the nature of missing data is missing completely at random, the best avoidable method in many cases is deletion. You can see that is after the first option failed, that you are not having the opportunity of going back to the original source to get the data, then you delete. You may do list-wise and you may do it pair-wise, depending on how, which type of the observation that is actually missing. Okay? So sometimes you might have to delete the rows that has the missing variables, like this. This is row-wise. You can see here. So this is one record. This record has a missing value under this feature. This is only missing value, so we delete it. This is called row-wise deletion. Sometimes, yeah, we have to eliminate the entire one. Well, however, sometimes you might have to go for the deletion of columns. In this here, we do that when you have so many missing value in a column with several missing value, then you go for deletion of the column, which is the safer option you may have, depending on the data you are actually modeling. However, if the deletion is not possible, then in that case, we move to the next option, which is the imputation method. Imputation method is the last option for us. We don't always go for imputation because imputation is like you are introducing a fake data, because you cannot always be sure if the replacement you are making is actually correct. And we actually demonstrated in the last section, whereby if we are go by the majority, we will be inputting the wrong value. But luckily, we were able to use the option of going back to the source, and then we got the original data from the source. That put us on a safer side. So always pay attention to this. Get the data that is as correct as possible from the original source. Next option is deletion, column that are having missing values, delete all of it if you have enough features. Or you delete rows. Imagine I have like 5,000 samples. I can still afford to delete as much as 2,000 without maybe compromising my modeling. Okay? Keep deleting, because to have original data is better than imputation. However, in reality, we face a situation whereby we don't have option, we have to go for the imputation method. And there are 4 methods of imputation. 1, replacing with mean. You replace the missing value with mean, median, or mode. You assign a unique category. Sometimes you assign a totally new category into this value. We do this for categorical variables. We'll see example shortly. Sometimes we assign most frequent value. You look for a most frequently used value in that data set that is common, and then you use it to replace the missing value. And then, last but not the least, sometimes you may have to use algorithms, that is machine learning algorithm that support missing value treatment to predict or to estimate the value that was missing. So this is going to take more time because you are going to build a model now that's going to help you to do the estimation of missing value. But these are all options that, and which option is better is fall back to the principle of let the data speak. Always remember this. See, you may have a problem at hand. That's why data science projects are better done in groups, a minimum group of 5 or more. Because there are so many things to be investigated. So when you want to pick by imputation method, somebody might investigate this, another one may go for this, another one will go for this. Even in this one, you may try mean, median, mode. You can see, you have to run the experiment for each of them and see, okay, which one is giving me better result? Is it the one treated using mean, or using median, or using mode? You have a lot of experiments to check because there is no one that is always good in all situations. You may have a particular problem now you are solving. This one may work for you. Next time you have another data set, it may not work. It may be this one that is going to work. This may not work for another data, it may be another one. That's why we always try to let the data speak. Try out as many options that are available for you out there before you conclude that this is the best way for me to treat the missing value. Because treating missing value, as I said, is actually creating using data or value that may not be correct, may now actually be right. And we demonstrated it last time. You see in that video where we saw that even the one that is majority is actually not the correct one. But then we don't have options. We use imputation when we don't have option. So it's not something you use as a first recourse. The first thing is to go back to the original source. The second option is to delete columns with more missing values or rows with more missing values. Last option, we do imputation. Now, the first imputation type is replacing with mean, median, or mode. This is where you can use the mean on the numerical data. See, if the data is numerical, like this, you can see, so we can calculate the mean of the entire, we call it global mean. You can calculate the entire mean, and then use that mean to replace any missing value we put there. Any missing value, we are going to put the mean there. See, sometimes we have the global mean, sometimes we have the group mean, depending on the kind of data you are modeling, how big they are, and then you might decide to create a particular kind of group for them. For this, we are going to use a particular mean for them. Otherwise, you can use a global mean. It means just find the mean of this column and then use that mean to replace anywhere you have missing value. That is treating, replacing with mean. Sometimes also you may find the median and then use the median to replace the missing value. Then you find the mode, then use the mode to replace the missing value. For example, you can use mode for either numerical or non-numerical. But when you have categorical value like this is a categorical value, you don't have numbers, then you look at the mode. Mode is going to be 1, 2, 3, 4, 5, 6. We have 6 Android there, iOS. So most likely then we are going to replace with Android. If anything is missing, luckily we don't have any missing value here. But if anything is missing, the mode is going to be Android. So we're going to use Android to replace all the missing values. This is how you handle the missing value with the main, median, or mode. It's very, very common, very, very also popular among people to use, especially the mean. However, know that there's no replacement that can guarantee that you are not missing important information because you are just making a guesswork. The fact that I replaced with mean does not mean that the value that was missing was actually 4.145. So this is a guesswork. That's why if we have opportunity to go back to the source, we don't do replacement. If we can delete that column to save us from the embarrassment of replacing with the wrong number or wrong value, we should delete that column. But if we don't have option, we cannot delete because we have so much few values, few features, few samples. Then we move on and do the replacement with main, median, and mode. Another option in treating missing value is to assign a unique category. See, we look at the categorical feature, for example, where you have a definite number of possibilities. For example, such as gender. Actually, when you have categorical features, like you want to know the gender of student, then popular, you have male or female. So when you have missing value in your data set, male or female, then some are missing. We don't know them. So instead of replacing with mode, the first method, which is to look at which one is more common. If it's male, replace with male. If it is female, we replace with female that are more common, the mode, because we cannot calculate the main. However, this option is saying, instead of replacing with main mode, because why don't you create a totally new category? So we can say, okay, we have male, female. Every missing value, we are going to call it unknown. Known. So you are creating a category that is not existing before. We call it unknown. During your modeling, the system will treat it as unknown rather than treating it as male. Because when you replace every missing value with male, for example, because it is the mode, then you are giving male more opportunity. And the answer may actually be female. So you are adding more to male while disadvantaging the female by more number you have added to male. So representing with unknown may be a good option. So that instead of having two categories of values there, you have male, female, and then unknown. And it could also be any other type of categorical value. This is what we mean by assigning a unique category. So the missing value can be treated as a separate category by itself. So you can you can call it you. Somebody's male, female, male, female, then you have some dash. Then you just say, okay, this is going to be you, this is going to be you, which means unknown. If the modeling is easier for the machine learning algorithm with it like that, you are not giving too much advantage to male at the expense of female. Rather, you are creating a category that is unknown. So is it going to give you a better result? We have to let the data speak. So you have to demonstrate it and see what result you are getting. So the strategy, we add more information into the data set, which will result in the change of variance. This advantage of using this method. So instead of adding more to male or adding more to female, rather you are creating a totally different category so that it doesn't affect either of the two that are known, because this value is just unknown. We're just trying to get a way of modeling it. Another option is to assign a most frequent value. See, the standard thing is to replace the missing entry with the most frequent one. You just look at the one that is most frequent, so that it's most frequently used, and you use it to replace. This is M. Okay, I'm going to say this is M. It's going to be M. So this is a simple method of using the most frequent value. It could be a number, and it could be a categorical value. It doesn't matter. For example, if I have a missing value here now, I'll look at which value here is common. 1, 2, 3, I think 57 is occurring, and 58. In that case, 55 also is occurring, 58 is occurring. So you have more than one, then you have to choose any of them that's most frequently used. Or else you may have to create for categorical a particular unique value that can be used. That is the third method of imputation method. The last but not the least method of inputting missing value is to use prediction algorithm. So you go back to machine learning itself and then use the algorithm to estimate what's supposed to be there. See? So we can create a predictive model in this case to estimate the value that will be used to substitute the missing data. So a lot of practitioners believe in this, but the effort is too much. It's going to take a lot of time because now you are going to build model before you start even building your own model. You see, you are trying to build a model, but now you need model to estimate values. Then how many values you want to estimate? You have several missing values. But some people still believe that it's really what maybe it will give you a better estimation than just replacing with mean. So one of the very popular algorithms that support missing value treatment is known as KNN, the K-nearest neighbor. K-nearest neighbor is an algorithm that works on the principle of show me your friend, I will tell you the kind of person you are. The closer you are to a particular variable, the more you are likely going to demonstrate the same characteristic of that value. That is, if you have a value A, B, C, D, E, it is believed according to KNN that these closer ones, they are closer together, they are likely going to belong to the same category, or they are likely going to be similar compared to the one that are far away from it. So it uses distance measure to calculate the distance between this value and the other values, and then it can determine those that are closest to it. So the majority of those that are closest to it, they are going to be the one that will be assigned the value as the replacement. So another method that is often used is we can check out K-nearest neighbor. It's one of the very popular and simple algorithm. It falls under the algorithm we call lazy classifiers. They are often used, they can solve both classification and regression problem, and they are advised to be used first before you go to more complicated algorithm. It's one of the principles of machine learning modeling. You start with simple algorithm, and gradually you move towards the complicated or more complex algorithm in case the simple one does not work. Because sometimes the complex algorithm may miss your insight that you are looking for in that data set, and the simple one may get it too. That is, again, the principle of let the data speak. Always remember this. There's no algorithm that is always better. It depends on the problem you are solving. So random forest is another algorithm that is often used to estimate. Missing value. So people consider it that it may produce a robust result because it works well on nonlinear and categorical data. Random forest is an ensemble model that is built from decision tree. When you have several decision tree built together randomly, then we call it random forest. Because when you put the tree together, many trees, they form forest. This is where the name comes from. So many trees are combined together in an ensemble to form forest. We call it random because, like the usual pattern of determining the next node to be used in the decision tree, this one uses randomization in selecting the next node to be used. Hence, it's referred to as random forest. A lot of work has been done in this respect, and it's often a claim that it may actually provide better results for us, but the way it all boils back to which problem you are solving. Let the data speak. So there is no particular method. Among all these methods, what are the best one? There's no one that is best. So it depends on the problem you're solving. And that's why I said you must be ready to check as much as possible options, especially when you are not getting good results. For example, you have to I just need to do imputation. I start with mean, which is very common. And with mean, I'm getting 90% accuracy. Excellent work. And your client says, it's okay. We are looking forward to getting 95. It's okay for you. You don't need to waste your time anymore. You see, you have gotten what you are expecting. You have even surpassed the expectation of your client. That is fine. You stop. In future, then you may estimate other. But sometimes you get stuck. You are looking to 95. You keep getting 80. You have used mean, used median, used mode. Then try other methods of missing value treatment. That could be the problem you're having. It may also be normalization that you actually need to go and check. So there are a lot of things that you have to put in your brain when you are doing your modeling. And that's why you have to consult experts, especially at the beginning, because experience matters. So based on experience, they can provide the necessary guide for you so that hopefully you'll be able to achieve your desired better modeling outcome. And finally, again, so what we're discussing is missing value, which falls under the pre-processing stage, data preparation, under further application engineering. Once you are done with your feature, with your missing value, then you move on to your modeling. Do your hyperparameter optimization. You always have that luxury of going back. There's no rush. Do hyperparameter optimization, change the algorithm. K-nearest neighbor is not working. Try decision tree, try support vector machine, naive Bayes. There are so many of them. Keep checking them and see what to get. Sometimes you will need to go back to data preparation again, feature engineering, or pre-processing like normalization. But the most important, that it's almost very important. We don't want to say it's compulsory, because if you are using decision tree can work with data that has missing value. So you can still do modeling with missing value in your data without a problem, because decision tree will naturally undo the missing value itself. However, if you are using any other modeling algorithm apart from decision tree, like support vector machine, you will get error if there's any missing value in the data. So it becomes compulsory for you to treat your missing value before you continue. That's why we can say that missing value is the most important and almost compulsory processing activity that you need to do. Every other one is optional, including the next one we are going to be treating later next time, which is going to be outlier. Sometimes you have outlier in your data set. It may be the Achilles heel of your data. It may be what may make you not to be able to achieve your desired outcome in your data model. So that is what we are going to have for the day. Thank you very much for listening. Wish you all the best. Thank you.